Welcome to the Physics Subject Selection video. Physics is a 2-unit course that will contribute to your ATAR. The rationale in the syllabus is a little bit dry, but it does tell us that it's about the study of energy and matter and their interrelationships. Now, given that nothing happens without energy and pretty much everything's made of matter, that gives us a whole lot of things to study. From the largest thing we know, the universe, to very, very tiny massless particles that are found in nuclear reactions. However, in this course, looking at the preliminary course, there are 4 modules, each of equal time, about 8 weeks of coursework, and these subjects build largely on work that you've already done in stage 5. So the world communicates relates to electromagnetic radiation and how it's used in communication. Moving about is about motion and forces, and the cosmic engine about the life cycle of stars and the life of the universe. Electrical energy, a little bit obvious. Moving to the HSC course, there are also 4 modules of about 8 weeks of course time. 3 of these are core subjects: space, motors and generators, and from ideas to implementation. They build strongly on some very important concepts developed in the preliminary course. The 4th one is an option, and medical physics and astrophysics are the most likely, but this will depend on class preferences at the time. The skills often relate to collection of data and analysis of data, and then using data to explain concepts. So we do real experiments to collect data. We try and collect as much data as we can when available, to use data loggers, and then to use spreadsheets and so on to analyse large amounts of data. There are quite a few mathematical formula involved in physics, but if you have the ability to enter data into a formula, substitute in, and then do the calculations, then that's largely what's required at that level. However, a deeper understanding of what a formula means and using that to explain a concept is a higher level of understanding that would be worthwhile. The assessment is largely exams, half-yearly and end-of-course exams, as well as research tasking, both preliminary and HSC course, and then a practical exam and practical reports that relate to practical work that is done during class time. If you're looking to study physics, it would be good to be competent in mathematics. You don't need to be doing well in 5.3. You can be doing well in 5.2. You will have a significant mathematical ability to achieve. Competent in science would be good. Creative thinking, good problem solvers is always helpful. And if the careers listed there are interesting to you, they're all obviously things that are going to be important in the future for developing technology and so on, then physics has a strong basis, or they all have a strong basis in physics, so all very, very important. Now, why study physics? Well, firstly, you can avoid looking silly like this, or if you were the cause of this at work, that could be quite embarrassing. And we can't explain why boys might do stupid things, but it can explain why the results are as they appear in the image here. More interestingly though, you might find it interesting to generate your own astronomical images. This is produced by one of our former students from black and white images developed from a telescope, and then they're repositioned into colour images, and this is a unique image attributed to this one student. Also looking at cool magnets, this superconducting magnets, which we saw at an excursion to Sydney University, and this is studied in the course, and it's exciting and developing technology with lots of potential. We might move on. Handling lots of data, this is from astrophysics, a spreadsheet that we've used, not designed, but our students have found all of the data here from astronomical images from telescopes, entered it into the spreadsheet to generate and analyse what's going on. There are lots of problems in the world, and problem solvers will become very, very important. Obviously, this one here is an engineering issue, and physics and engineering will have solutions to a lot of the world's problems. The energy crisis is a big issue as well, so generating more efficient transport and renewable energy sources and more efficient housing will all become very, very important, as well as livable cities. As populations increase and there's more and more people there, we can't be using more transport and burning more fuel. New materials will also make houses and buildings more efficient. This carbon composite will be used to replace metal in cars, which could also be very, very useful. And new developments in computing in the areas of photonics and quantum computing promise to deliver very, very vastly more powerful computing, which may see virtual reality and artificial intelligence become far more common things that we might be familiar with. Medical industry is an area that's already relying heavily on physics using CAT scans and this is nuclear imaging and ultrasounds and so on. Here we have a doctor using a robot in surgery. Now, this is becoming a reality. There is one at Westmead, so very big physics focus there. Chemical design for drug design using computing, and simple engineering solutions to develop, in this case, one-use needles so that there is less spread of disease through needle sharing. Better communication is something we're all keen about as well, not necessarily a problem, but newer phones require better batteries and better materials, better circuitry. There are literally hundreds of satellites orbiting Earth, and our data travels around the globe in fibre optics. So that's all very important as well. So if you're interested in any of these ideas, or you're just looking for a subject that's interesting and could certainly boost your ATAR, then you certainly shouldn't discount physics. Thank you for getting this far through the video, and good luck with your subject selection.